graphing part of the notes. So graphing starts on page 202. So go ahead and go to page 202 and evaluating part. Okay, so here graphing logs. So the important thing to remember between exponentials and logs is that they're inverses of each other. So if they're inverses, that means we're going to switch everything around. We're going to switch the points, the intercepts, the asymptotes, all that stuff, and the graphs are going to be reflections over the line y equals x. So I'm not going to ask you to graph these. I just want to graph the first one here, just so you can see what the graph looks like. So the graph that's here right now, this graph is the exponential function that's given over here. So this exponential function has a horizontal asymptote at -2 and has these points. -2 is at -1 8/9. -1 is at -1 2/3. 0 is at -1. 1 is at 1. And 2 is at 7. So those are the points here. The domain, this graph's going to go left and right forever, so all real numbers. The range is not going to go lower than the asymptote, which is at -2. So the range is going to stay y is greater than -2. And then my two intercepts are the x-intercept at 0.630 and the y-intercept right here at 0, -1. So the first thing we want to do is get the graph for the new one. So the way I get the graph for the inverse, which is the log, is all I'm going to do is switch these points around. And we're not going to graph all these points because some of them are too small to graph, but we can write them out here. All right, so this point's going to be -1 8/9 and 8/9, -2. So I'm not going to try to graph that one, but that's what it's given. Here, I can try to graph this one, -1 2/3, -1. So -1 and 2/3, just a little further out, and -1 about right here, actually a little bit more than halfway. So somewhere right here. 0, -1 switches to -1 0. So -1 0 is right here. 1 1, when I switch 1 1 around, that one's actually going to stay 1 1. So 1 1 stays here. And when I switch to 7 around, it switches to 7 2. So 7 2 is out here. So this graph starts off like this, and then instead of going flat, it actually goes vertical. So these are vertical lines where the asymptotes are at. All right, so that we're going to get to the asymptote in just a second. But this side still goes up and out forever. I know it looks kind of flat, but it's still going to continue up forever. All right, so that's how we get the graph, is we flip the points around. But what we have to do for the information is switch the critical values. So for domain and range are actually just going to switch. So the range is going to come here to domain, the domain is going to switch to the range. So then the range is going to be all real numbers, but it's a y equals, because this side's going to go down forever, and this side's going to go up forever. And the domain now becomes greater than -2, but it's x equals because it's the domain. So make sure you put x's for domain and y's for range. So again, this graph is not going to go past -2. It's going to get closer to it, but not actually past it. For the intercepts just switch. So my x-intercept is going to switch points around, and now it's going to be a y-intercept because 0 is now the x-coordinate, so 6 3. And my y-intercept is going to switch and now be an x-intercept because 0 is where the y is at. Right, so I already have this point, -1 0, but the other one is this one right here at 0.63. Right, so it's not always going to have both. Some of them it's not going to cross. It doesn't have to have a y-intercept. This one happens to have both. Right, and then the last thing is the asymptote. So in the exponential, we had a horizontal asymptote. And horizontal line is y equals -2. So that's where this graph flattened out. So this graph flattened out at -2. When we switch it around, we're actually not going to switch it with anything. We're just going to change it to an x equals equation. So x equals -2, which is a vertical line. So again, instead of this line going flat, it goes vertical right here at -2. So that's the graph of the logarithmic, not this one, I'm going to erase this one. This original one was the exponential. The red one is now the graph of the log. Right, so on the homework, you're going to type in all the information for the logarithmic graph using the exponential and switching it around. Right, so let's do one more where we're not really graphing it. We're just going to switch the values of the information that it's giving us. All right, so looking at example 9. So here it gives us the points again for this graph. I'm going to kind of ignore the points and just do the critical values. So the first thing is that the domain and the range switch. So the domain is going to come here and now be the range. When it's range, it's y equals all real numbers, because it's going to go up and down forever. And the range switches to the top and becomes the domain, and domain is x is greater than 0. So range is y, domain is x. Make sure you keep those variables consistent. The asymptotes also switch. So here, my x-intercept for the original one didn't have one. So this graph never crossed the x-axis. So this graph is never going to cross the y. So NA or none if it doesn't cross it. But now it will have an x. So if the original doesn't have one, the inverse is not going to have it when you switch it around. So again, over here, it crosses the x-axis, the y-axis at 303, but it doesn't cross the x-axis, it just gets closer to it, so we just say not here. And then for the asymptote, this one had a horizontal asymptote at 0. That's where the graph flattens out. When I switch it around, this becomes a vertical asymptote, and I type it in as x equals 0. So again, you're going to type in the x equals 0 part, not the vertical asymptote part. All right, and if we wanted to see the graph, you would just switch the points around. So you would just take each of these points and switch them around, and then actually graph those new points to get your logarithmic graph. So 1/3, 2, and 1/9, 3. All right, so you can graph it, but you don't need the graph in order to get the information. Alright, so here's the last one. Again, just getting the information for this one. I'm not going to graph it. You can graph it if you want. Just switch the points around. But just so you know how to do the ones in the homework. The x becomes the y. The domain becomes the range. The range becomes the domain. Just remember to change it to an x is greater than 4. The intercepts. The x-intercept becomes the y, so now it doesn't have a y-intercept, but now it does have an x, so 12, 0. And then make sure when you type it in, you are switching these two around. So 0, 12, make sure you type it in as 12, 0 when you switch it. And the asymptote was horizontal at y equals 4. It's going to flip to vertical at x equals 4. So the signs don't change it, positive, negatives. All you're doing is flipping it around either from x to y or flipping the actual points around. All right, so again, to get the graph, you would just switch the points around and then you would graph your new one. look to graph these. Again, we don't graph like logs all by themselves. We have to look at the exponential in order to graph them. So we're going to make a table for the base exponential. So we're only going to look at, so if the base is 2, we make the exponential for base 2. If the base is 3, we make the exponential for base 3. And then we'll switch those points around. All right, so here the red graph is the graph of the exponential function with a base of 2. So this graph is 2 to the x. So y equals 2 to the x. And my points, so at 3, it's 8. So this point's at 3, 8. 2 squared is 4. 2 to the 1 is 2. And anything to the 0 is 1. For my fraction, for my negatives, those end up being fractions. So at -1, it's a half. At -2, it's a fourth. All right, so that's how I get the table for my exponential. I plug in the exponents. To get the log table, I just take those and switch them around. So I'm just going to take the y's and make them the x's, and take the x's and make them the y's. And these are the points I graph. So again, I have to do this because notice the x's don't go in order. If you try to graph this in order, like half of them aren't going to give you a point. Negatives aren't going to give you a point. And a lot of the numbers in between are decimals. So we just want these endpoints. So here we can graph, we're flipping these points around. So 8 is at 3, 4 is at 2, 2 is at 1 now, 1 is at 0. I go halfway, it's -1. And if I go just a little quarter of the way, it's -2. So I connect those dots. This is the graph of the logarithm. So when I ask you to which one's the log graph, it's not going to look like the ramp shape. It's the inverse of it, which I don't know what you want to call this shape, but this is the graph of the log function. So again, it goes vertical, has a vertical line, and it goes up and to the right forever. So that part's going to be the same. The part that's different is now the asymptote's a vertical line instead of a horizontal line. So here we have a vertical line as the asymptote at x equals 0. That's your vertical asymptote. My domain is going to be all numbers more than 0 because it can't be 0 or negative. And my range is still all real numbers because it's going to go down forever